Okay, so here's where we were. We were at trying to find the the x-intercepts. Okay, and so we had left off where saying that the y is 0 on both of these. See that? So we're going to replace this with y. Okay, I should be with this with 0. So we put 0 equals 2x, 2 times x minus 5 squared minus 3. So here we're going to do a little bit of reverse PEMDAS. Okay. So this cancels out. Now you're going to have 3 equals 2x minus 5 squared. So you can get rid of the square by square rooting this and square rooting that. And the square root of 3 is, what's the square root of 3?
Checking my sources. The answer is 9.
Ah. What's the square root of 3?
Looking. It looks like the answer is approximately 1.73205.
Okay, so Siri says it's $1.73. Okay, so the square root of 3 is about 173. Okay, equals 2x minus 5. So when you square root it, the 2 disappears. But there is another one. Square root of 3, it's negative 1.73. There's 2 answers that are the square root of 3. Equals 2x minus 5. Alright, next, so we have 2 equations. So this one now you're going to add the 5 to both sides. Okay. Notice I put the 5 underneath the 1. So this is $6.73 equals 2x. Lastly, divide by 2, cut it in half, cut this in half. Okay. So one of the x values will be half of this. So that'd be 3 into 6 is 3, 3 into 7 is 3 with 1 left over, 3 and 13 is 6, okay, with 1 left over, and that would be 12, 366. And looky, look at this, 3.366, we got 3.366. So that's going to be one of our intercepts. Oops. 3.366. Okay, and the other intercept will be the other part of the equation. So then you gotta do it. I'm gonna add 5 to both sides. Okay, add 5 to both. Okay. That cancels out. So this is 5 minus $1.73. That'll be $3.27. 3 divided by, equals 2x. So 2 times, what is that? Well, 2 times half of this will be that. So divide by 2, that cancels out. Divide by 2. So x will be half of that. So 2 into 3 is 1, with 1 left over. 2 into 12 is 6. 0 left over. That'll be 7. 2 into 7 is 3. With 1 left over, it'll be 12. There we go. So 1.636, 1.634. I'm off. by just nothing. So here's your other intercept. That'll go right in here. Alright guys, so this is the challenge of how to get the x-intercept of a what's it called? Vertex form. Notice how Desmos does it all for you. Of course, we can't use this in a test because that'd be no challenge. What you can use is your knowledge of the x-intercepts having y is 0, the vertex being on the middle of the axis, and the y-intercept having a 0 as the x. And there's mirroring points too. See this one right here? 522 mirrors this one right there. Alright. Lastly, on this, I want to cover when is the function decreasing. Okay. I want to know when is the function decreasing. So look at the value of x's. See at look at the y's now. The y's are going down. Just look at the graph. It's very visual. It's going down. The y's are going down, and then it started increasing here. So where is the graph decreasing? Well, it's decreasing from here all the way to here. So where does it start at? Does it start at negative 0.3? Well, you can zoom out more. Does it start at negative 5.1? No, you can keep on zooming out. Does it start at negative 12? Nope. You can keep on zooming. Does it start at negative 24? No. Does it start at negative 50? Does it start at negative 105? Does it start at negative 258? Does it start at negative 1000? See that? So the point of it is that and I'm going to put a function notation here. Excuse me, interval notation. The graph is increasing. Okay, the graph is increasing. That means the y's are going up. The y's are going up when x is some very, very big negative number all the way to right here when x is 2.5. Okay, so any number, any negative number, basically anything less than 2.5. So the old way you would write this would say, oh, when x is less than 2.5, that's when the graph is going down. So this, I think most of you understand this already, is the same as this. Whoa, what the heck? My infinity, from negative infinity all the way to 2.5. This is when the graph is, oh boy, I messed up. Not decreasing, not increasing. When it's actually what? Decreasing, when the y's are decreasing. The y's are going down. Just look at the graphs going down. So when is it increasing? Okay, it's increasing, well, when x is greater than 2.5. You can say, well, it'll go from 2.5 all the way to forever. So this means the same as that. And this means the same as this. This is called interval notation. Interval notation. And that's it. Okay. The domain are all the x's that could be here. Looks like any x is here. The domain are all the x values, which are anything. And the range are all the y's. Notice the y's, there is no y less than -3. Okay, so this is the last piece of this puzzle here. We have the domain, as I say domain, x equals any number. As I say any, this is like a code. This means any number, any real number. And the range, the y's will always be bigger or equal to -3. Alright guys, that's it for now. I'll make 2 more videos for the standard form and for factored form.